Hi, this is Team Awesome. My name is Ong Du Heng.
My name is Bonnie Lee.
My name is Zishao Xiao.
So this video we will show you the demo of our lab one. First, we'll run our code first. As you can see here, there is beeline 49 system calls, even though we only called one system call, which is in our main. That's because in the lab manual, it is stated that the other system calls, such as fork, execute, the other systems have been made even before the system info has been called. So for the professor info, this is a processor's info. So this has worked as we expected. So when we try to import to child process with 65 megabyte, it returns with 10 sister cores. Each has 21 page usage. Okay, Zoe.
Okay, so what I did is the sysinfo function. First, we want to get the total number of active processes in the system. And to do that, we use a for loop to iterate through each process. And we use a log to ensure that no interrupt are occurring while we're checking. And when the param is 1, we want to return the total number of system calls that have been made since the system starts. So in order to count the number of system calls, we declare a new global variable, which is total syscall. And then we increase the number of total syscall by 1 whenever the system calls have been made, and then return the total number of system calls. Okay.
Okay, so when the user inputs param equals 2, it will return the total number of free memory pages in the system. So how it works is that to check it, we define a new function called the in-frame pages, which is defined here, and which is implemented in cloud.c. So what is written right here is that we first initialize R to the memory in the linked list, and then we count the number of the free pages until the R reaches the end of the linked list. Okay, so I'm sorry, Bonnie.
Okay, I worked on the proc info function. So first of all, we need to declare a struct pinfo, and then it has 3 members, which is PID, system call count, and page usage. And then inside of the function, we first check if the input pointer is null. If it is, then we will exit the function. And then we use the copy out function to copy the length bytes from kernel address to our user address, since the kernel cannot directly write data to the user space memory. And then we just use that to copy 3 of those members in the struct. And then we calculate the current process memory size in page, and then we divide the size of process memory by the page size. So that we check if the process memory size is divisible by the page size or not. If it is not, then we need to add 1 to the free memory pages.